Running a SaaS platform with hundreds or thousands of tenants means complexity grows fast. In a monolith, one schema change can ripple across billing, notifications, and analytics. One overloaded tenant can slow down everyone else, and a single failure can bring the entire product offline. To handle this, SaaS companies rely on established microservice architecture patterns. These patterns define how services are structured, how they communicate, how tenants are isolated, and how the system remains resilient under pressure. In this video, I'll walk through the patterns that matter most for SaaS, starting with the foundations, then moving into resilience, multi-tenancy, data and workflows, then security, operations, and finally the migration path from monolith to microservices. If you're new to this channel, I would request you that please subscribe to our channel and press that bell icon. I share deep dives like this on SaaS, AI, and product strategy every week. We also send a lot of free giveaways like ebooks, templates, and worksheets to our subscribers regularly. The first building block is the API gateway. This is the single doorway into the platform. Every request flows through it, where authentication is applied, quotas are enforced, and tenant-specific rules are checked. For SaaS, this is also where you guarantee fairness between tenants and keep the backend protected. The second foundation is strict data ownership. Each service must own its database. Billing does not reach into orders. Notifications do not query analytics. This boundary prevents cascading failures, enables independent scaling, and makes it clear who is responsible for each piece of data. Once those foundations are in place, the next challenge is resilience. SaaS systems cannot afford a single failure spreading everywhere. The circuit breaker pattern addresses this by detecting failure services and cutting them off before they overload the rest of the system. The platform continues operating, and when the service recovers, traffic resumes. Service discovery is equally important. With services scaling dynamically, instances appear and disappear constantly. Discovery registers healthy instances, removes unhealthy ones, and ensures traffic is routed only where it belongs. This mechanism allows distributed systems to remain stable even under heavy load. Now, multi-tenancy is the heart of the SaaS, and the isolation model you choose affects cost, compliance, and pricing strategy. The pool model uses one shared database where each row is tagged with a tenant ID. It is cost efficient but requires very strong controls to avoid data leakage. Where the silo model gives each tenant a dedicated database. It provides maximum isolation but with higher operational cost. The bridge model is hybrid. Smaller tenants share, enterprise tenants are isolated. Many SaaS companies choose this approach because it balances efficiency with enterprise expectation. These choices go beyond technology. This determines how you price your product, how you handle compliance requirements, and what guarantees you can give to enterprise clients. Now, microservices change the way data and workflows move through the system. Event-driven architecture is the backbone. Instead of direct service-to-service calls, you publish events. An order-created event, for example, triggers billing, notifications, and analytics independently. In compliance-heavy SaaS, event sourcing and CQRS add more power. Event sourcing records every change as an immutable event, ensuring a full audit trail. CQRS separates reads from writes, which allows reporting and analytics to scale without impacting transactions. Workflows that span multiple services rely on the Saga pattern. Booking a trip, assigning a driver, charging a payment, and sending confirmation all require coordination. Saga manages those steps, and if one fails, it rolls back the process with compensating actions to keep the system consistent. Now, two capabilities define whether enterprise customers trust your platform: security and visibility. Security patterns include OAuth 2 and YDC for authentication, MTLS for service-to-service communication, tenant scoped quotas and rate limits, and immutable audit logs for compliance. Observability makes the system transparent. Distributed tracing follows a request across services. Centralized logging ensures every log entry includes tenant context. Metrics expose per tenant reliability and performance. Together, they allow you to meet SLAs, spot problems quickly, and give customers confidence. In production, SaaS microservices usually run on container orchestration platforms like Kubernetes. Each service runs in its own container, scaling independently as demand changes. Blue, green, and canary deployments reduce risk during releases. Infrastructure as code ensures environments stay consistent, and serverless functions are often used for vastly event-driven workloads such as notifications or background processing. Now, most SaaS products start as modular monoliths, not microservices. Migration should be deliberate and gradual. The strangler fig pattern routes one domain at a time through new services. Branch by abstraction introduces an interface and then switches the implementation behind it. An anti-corruption layer shields the new services from legacy code during the transition. The first services that are usually carved out are identity, billing, and notifications because they are distinct and easier to isolate. Core workflows like reservations or tasks follow later once the boundaries are clearer. To recap, API gateway and database per service are the foundation. Circuit breakers and service discovery keep the platform resilient. Multi-tenancy models determine cost, compliance, and enterprise readiness. Event-driven architecture, CQRS, and sagas make workflows scalable. Security and observability are non-negotiable for trust, and migration should be gradual, moving from a monolith to services step by step. Now, these patterns make SaaS platforms sustainable at scale. Applied correctly, they allow you to onboard new tenants, expand into enterprise, and operate globally without losing stability. Now, this can be a little complex for a lot of us to understand, but this is going to be important if you move into enterprise SaaS. So if you want more such backgrounds on building SaaS, AI products, and scalable architecture, please subscribe to the channel so you do not miss the next one. See you soon.